So here's our problem. This is supposed to be a dock back here. And here's a boat in the water alongside the dock, a little sailboat. And this sailor is pulling on a rope and is moving the boat along the dock. And pulls the boat for 30 meters and has to pull with a 220 or 255 Newton force. That's a pretty strong pull, by the way. So he's transferring energy out of his body into the boat, but now this boat probably isn't accelerating, right? So he's not only pulling he's trying to do work on the boat. He is doing work on the boat, but there's other things that are doing work on the boat that's kind of slowing it down, right? I mean, think about what he's doing. What changes to the environment is the sailor making as he moves the boat along the water? Yeah, the water gets stirred up, right? It's really the friction or the stirring up of the water along, in here, that's where the energy's going, really. I guess the boat has a little bit of kinetic energy. If the boat started from rest and then he brings it up to speed, he gave the boat some kinetic energy, but then as the boat reaches constant velocity, as you're walking along the deck here, along the dock, you're stirring up water, maybe you're making noise, so those are all changes to the environment, and so that's which means that he's transferring energy out of his body into the boat and into the boat into the water and so on. But I want to know, how much work did this sailor do? Well, with that force. Well, for all the forces we're going to do in here, you can use this formula. Work done by a force. Now, work is a scalar. It has no direction. Even though, delta x is a vector, and the force here, the force the sailor applies, is a vector. We're going to use the dot product to figure out what the work is. And this means that, now this dot tells you to do something. The dot says, hey, take the magnitude of this vector and the magnitude of this vector and multiply that by the cosine of the angle between them. Well, if I hook these two vectors up, 255 and then delta x looks like this, right, is in this direction. The angle between them when I hook them up tail to tail is 25 degrees. And we've got it. The work done by the sailor is, if you plug all that in and round it off, 6,930, if you round it off to 3 significant figures, joules. That's our answer. Now that means that the sailor has 6,930 fewer joules left in his body, stored up. Where do you store energy in your body? There's several places. There's this sugary kind of stuff in your muscles that allow you to move around, called glycogen, right? Have any of you learned that in anatomy, physiology, or biology or something like that? It's called glycogen. There's a chemical reaction. It's chemical potential energy stored in the body, and took that energy and transferred it into the boat, and then from the boat it went into the water and just dispersed into the environment. Okay? Didn't disappear from the universe, but it's no longer in his body. So he's got to go have lunch after he does this, to replenish that lost energy. That is all.